Hi, welcome to this management science tutorial entitled Linear Programming. In here we are going to look at a workshop. We've got a couple of employees which produce mugs and bowls. We have got 40 hours of labor a day available, and we have got 120 pounds of clay available for producing these two products. They are sold and with a profit of 40 and 50 pounds. So for bowls we earn, we have a profit of 40 pounds, and for mugs 50 pounds. Good. So what do we want to achieve? We want to first transfer this table, into Excel. We are going to transpose it, formulate an objective function, formulate some constraints, enter decision variables, create the formula in Excel, and also put the other parameters in there, and eventually use the solver to get it all done. Okay, let's start the work. So first we want to enter the table. So as I said, we want to have mugs and bowls, and we have got the labor constraint and the material constraint, which is in our case clay. So this is all per unit. I'll just join these cells and put it into italic. Okay, what are the values? The values are, to produce one mug it takes us 1 hour, and to produce one bowl it takes us 2 hours. For the material we need 4 pounds of clay to produce one mug, and 3 pounds of clay to produce one bowl. Okay. We also have got the profit. I'll still wait with that a bit. So what do we want to decide? We want to decide how many mugs and how many bowls shall we produce actually, so the volume, the quantity. So I'm just going to enter some arbitrary values, which are 10 mugs and 5 bowls. So immediately we do see, if we have these values, then it takes us of course 10 hours to produce the mugs. Okay, let me just put some units in there. So format cells, and I'm going to enter a custom unit, which is in hours. And here we have the material, which is clay, again a custom unit, which is pounds. I could of course, to be completely correct, I should say 1 hour per unit. Okay, now to actually have it all together, so the total, we have to multiply with the volume, so 1 hour with the volume. Alright, so I could just copy now this formula into the next row, but then when I drag down the formula it will be slightly incorrect, so I'm going to fix actually our cell B3 now with the key F4. Fix it to the line 3, So 10 and well, 5 times 2 is 10 as well. And now I can drag it down, the formula, because I fixed the cell. 40, 40, and 3 times 5 is 15. All makes sense. Let's just copy the units. Okay. Then we have got some limits as well on the time and on the material. So how much time did we spend right now? Well, this is just this 10 hours plus the other 10 hours. And how much material did we use? 55 lip pounds. Good. Okay. And our limit, our constraint. Well, let's put. I'd rather call it limit actually. Limit is given, and our limit is 40 hours. So basically 5 people working on it, and 120 pounds per day. This is also per day actually. So let me just center these 3 things. Okay. So as we see, we have some slug there, so 20 hours of time slug and 65 pounds of clay slug. Of course, this might vanish when we actually find the correct volume. So we would like to find the quantities, the correct quantities, so volume quantity. Maybe I should call it quantity as well. Quantity. So how do we find that? Well, by maximizing the profit. What is the profit anyway? The profit per unit is given, which is, what is the profit per unit? 50 pounds. I think it's 50 pounds. Let's just remind ourselves what was the unit. So 40 pounds per bowl and 50 pounds per mug. Okay. $40 and $50 pounds. That means what is the total profit? That's just a multiplication. Total profit is 10 times 40 and 5 times 40, 400 and 250. Makes sense. What is, so the sum of this we would like to actually that's our objective, to maximize this profit. Okay, I'll just put it on top there, that we see how much profit we actually make with the right constellation. So that's the 400 plus the 500. 400 plus, not 500, 250. Here we are. profit. So this was profit per unit, profit per product, and total profit. So this is what we want to maximize. This is our constraint, so we cannot go beyond this daily limit. Okay, so constraints. So 20 must be smaller or equal to 40, 55 smaller, 120. We actually have some tasks in our original. We have some tasks in our original specification. So I'm going to look for an online LaTeX editor to actually put in the formulas. So I'll just Google that, and here we have found one. And the tasks which we have are: formulate the objective function on paper or LaTeX. So probably you would prefer to write it on LaTeX. So what is the object function? I'll call it fx, and this is to maximize the profit eventually, which is 40 pounds with x1. x1 is the number of bowls plus 50 x2, which x2 is the number of mugs. So here we see a nice formula. Let's make it a bit larger and copy that into our Microsoft Excel. So this is x1 and this is x2. So these are our decision variables, and we want to maximize fx. Okay, let me just do that quickly. So maximize fx, max, what are we maximizing over? x1 and x2. And we could write that even nicer. So this looks perfect. Here we go. What else should we do according to our specifications? Probably the constraints. Yes, formulate the constraints. Okay, back to the LaTeX editor. Back to our LaTeX editor. I've got it here already. So this is our material constraint. And on top of that, we also need the constraint for the time. So please note that this very much looks the same. 4 times 3. This is exactly, that's 40 and the 15 which we have got here. And if we add them up, it's the 55 pounds. Okay, so same for the time. So it takes 1 hour for 1 mark and 2 hours for this one, for the bowls, and we have got 40 hours. So this is our time constraint. Perfect. So now we have done all the basic tasks. Let's double check, have we done them? We have transferred the table into Excel, we formulated the objectives and constraints, we entered some decision variables and determined the profit per product. We created the formula for the objective function, that was the sum on the top. We entered the labor and clay parameters and computed the resource consumption and the constraints. So we have done all the fundamental tasks. Now the next set of tasks is actually to use Solver to determine our decision variables. That means the number of marks and number of bowls. So these two. So that's x1 and x2. Good. So if you start the solver for the first time, then you will have to activate it. If you have started it already, then you should find it in your data ribbon here on the solver, in the analysis box. So if you have not done it, so what you do is you go to File, Options, the second from the bottom, then go to Add-ins, then at the bottom you see Excel add-ins and say Go. Now you're very happy because you have got here the analysis function, probably written in English, and the solver, and you just tick these two. Well, actually, for this computer lab session you only need the solver. Later you will need the analysis functions as well. And click OK. So now you should have the solver in here. Okay. Now, yeah, English language would be better. Anyway, the objective is to maximize the profit. So we want to maximize, not minimize. We could also go to a certain value. Then the decision variables, these two cells, B4 and C4. Now we need the constraints. So we add a new constraint. Well, actually we're going to add both in one go. So we do know that the used material and time must be smaller than their limits. And since we're maximizing, we don't really have to be too concerned about negative values. And we are going to use the classic standard simplex algorithm. And then we are going to solve it. So we have found some result. You see the decision variables have changed. We say okay, we accept the new solution. We do see that the profit, we can't read that, so I'll just resize this value. And we see 1,360 pounds is the maximum profit which we can make by creating the right production mix. So, excellent. So our last task is actually to display that properly in a nice pie chart. I'll just take any. Well, I should have selected a little bit more. Let's undo that again and use mark and ball as well. Insert pie chart. Nice 3D chart. with beautiful design. And of course we probably would like to have some percentage and other stuff in there. Is a ball of 25%, 75. We could of course play around with some other layouts if you wanna rather have the numbers. Well, I'm just going to stick with the first one for now. So this is the optimal production mix. So 1/4 of our production should be balls, and the 3/4 of the production should be mugs. And I hope you enjoyed this tutorial. I'm looking forward to see you to the next one. Thank you.